Quarterly. Very happy to have everybody that was willing to drive down and see this great facility. I want to thank our Heidelberg materials friends and Michael and Wendy for all of the behind the scenes work to get this together. I want to welcome everybody here, but also online. So I think we had 18 registered for online and this option, so people that aren't able to make the drive, some conflicts and things, so can get the material and information. So I just want to remind you to keep it on mute if while it's going. You can add questions to the chat or chime in right in the Q&A right when we have the presentation for that. So you keep things moving smoothly. And then we have Adam here doing that, so he can let us know when there's a question. Sorry, Aiden. So the partners, we have the executive committee, so behind the scenes for these quarterly, help work on a number of things for there. My name is Teresa Colson. We have the rest of our officers and members. The majority of us are here are online. Today, we have a little red tag, so if you have questions about partners, wanting to host, just in general, whatever, that's a good place to go for questions. If you don't know, we'll find that out for you. Our membership, we're currently at 92 members, which is phenomenal. Number 4 there. And so they're on the state. We've had just a couple changes over the last bit, so there'll be some updates for there. But if you're in Indiana, have a business in Indiana entity, you're welcome to be a member for that. We do have on our the webpage, the item webpage, there's a partners section you can find, which has these details if you want to know more. Who is a member, right? Those sorts of things, and then also applications. There's information on the webpage of events such as this. So I know you get a lot of email blasts from Jean here in the back for that, but if you want to just kind of check, hey, what's upcoming, what's been in the past, some of the presentations, it's a really good resource to go see things that we've talked about before or things that are yet to come. So if you're not a member, it's a streamlined process to get to be one, and there's applications for that. If you have questions, members of the committee, probably existing members even, to work with you and kind of talk through the process and steps and what it'll be. So, and it's really good. There's a lot of benefits to being a member. One, right, the benchmarking, get to see other sites. And then, of course, hear about a lot of the pollution prevention or sustainability things that our members are doing, each and every year, making a lot of progress. So more on membership, it's free, it's voluntary for that. The only commitment you have is, meeting the pledge and doing continuous improvement, right? Most of our members have a ISO management system, or they have a version of a management system for that. So it's already work, right, that you'd be doing. And then we have an annual APR certification that you're required to do for that. So we talked a little bit, we've talked before in previous meetings. So we are currently Partners for Pollution Prevention. And it's great. There's been a lot of great work and things. With things changing, the committee, we're moving to Indiana Partners for Sustainability. We felt, and so Ivan has helped with the logo change for that. So it's more encompassing. Pollution prevention is each part of sustainability, but then there's other, there's other things to do. Looking at it, there would be more opportunities for partners to be able to fulfill their commitments for continuous improvement. We can reach more groups. Just kind of highlighting some of the things that we have on the board for there. and definitely, be able to, increase categories. So we're hoping in the future for the APRs to have more categories and things that we can report, on there. Networking, is also another good benefit of, being either an attendee, right, or a partner. So we have a LinkedIn group, and a Twitter group. But you can also invite your colleagues to come, right? So you can have multiple people come to the events. And then we also have materials at the conferences. So in the back, Jean's brought, so we have, the CTAP, which is a, free and confidential from our, from IDEM. That, it's a program if you have an issue, right, you need help working through, you can contact them. They've got, training professionals that will be able to, help work through a problem you may be having or a potential one you may have. We also have a flyer in the back about the clean community, for air. And so, Carl was talking about the re-imaging of some of the pictures and things. So you might want to check out, this flyer too. They're in the back. There's a QR code if you'd like to just take the picture and have it on your phone. And then ESP, Environmental Stewardship Program, works with the, this partners group, but it's more, right? So it's, a little bit more involved. It is great. It has a lot of, permit and other regulatory benefits. So if you're not a member of that, want to kind of understand what that is a little bit, getting see me or someone on a committee, right? We can talk to it. So it's great programs. Once you're in, you get to meet and do different things and then hear stories about what they're doing. So I've personally been, inspired some things that people have done at their sites and we've been able to implement at ours. Save the dates. So you're talking about these quarterly meetings. So our next quarter is our conference. It's on a Tuesday this year. Always, it's been a Wednesday, but this year it's on September 17th. There should already be an email blast for that. We have some early bird registers. There is a discount if you register early. We do have some sponsors still available and exhibitors. So if you'd be interested to have a booth there, heard from a lot of exhibitors, we get a lot of traffic, lots of good conversations and leads. December, we started last year doing a virtual. December's busy, the weather, people traveling. So we decided to do a virtual again for this year as well. And we're in process for spring and summer next year, which means if there's an interest, right, from anybody, please talk to us. Jean's great about helping work to get the details in, what needs to happen. So things, run smoothly the day of, but trying to keep the dates in front of everybody, our calendars fill up full pretty quick. If you're interested in hosting, you can do this email link, or like I said, anybody on the committee. So again, I want to thank everybody for coming today. I'm very excited to hear about the information that you guys are going to provide, and then the tour. Any questions so far? Great. Thank you, Teresa, and thank you all for coming down to the beautiful convention in Indiana. I will give a quick plug for the spring. If anyone hasn't been to the Spring Mill State Park down here, I know that the in itself is undergoing a renovation, but it is like an amazing park. They kind of have a village a little bit, if you're familiar with Indiana or Noblesville. Conferry, thank you, where they have like people actually there and, interacting. And there's a lot of history. We were formerly Lehigh, we rebranded the Heidelberg Materials, but there's this company has been in business here for over 125 years. And so there's a lot of history with this company here in this area. We actually donated kind
property for the park. You can actually, there's a place you can hike up and see an old kiln. There's a lot of references to Lehigh at the museum, but the park is just beautiful. I took my family down there and we camped, and I definitely recommend it. So thank y'all for coming down. Thanks to Michael Hardy, he's the environmental manager there here for hosting us. He's gonna kill me, but I'm also gonna give a quick shout out. Thank you to Jeff Pollock. Jeff has been with Heidelberg Materials for how long now? 20 years. So Jeff is the environmental manager for our aggregates business line in central Indiana, northern Indiana, and northern Ohio. When I was in consulting, I was part of the executive team, and when I left and came to Heidelberg, I couldn't be on the executive committee for the partners any longer because we didn't have an operation who was a partner. And I went to Jeff. I said, Jeff, how about we be the first quarry in Indiana to be inducted into the partners? And he said, absolutely, great. And so he helped out and put the application together and comes to the meetings and participates. And so, yes, we have the first and only quarry in the state of Indiana to be inducted to the partnership. We will get the cement plant. We will be submitting an application, but we've had a lot going on, which we'll talk about. So once things get a little bit quieter, we'll definitely submit an application. So thanks to Jeff, we wanted to step up and become a partner. So he submitted for our Harding Street quarry, which is right down at Harding Street and 465. One of the largest, top 2, 3 quarries and top 3 quarries in the Midwest. So great operation there. We would love to host a tour there. It's a little more complex than this site. We don't have a large facility to host and a quarry tour. And unfortunately, we won't be able to go out to the quarry today. It's a little complex trying to get a group safely out to the quarry sites. We have a lot of large moving equipment, very rugged roads. You have to rent buses. It's a little bit, but hopefully we can give you a little sneak peek of the quarry while we're here. Kind of what we're going to talk about today. We're talking about our, a bit about our company. Michael's going to talk about actually the cement manufacturing process. Before I joined the company 4.5 years ago, I'd never stepped foot in a mine or even thought about cement operation, right? I had to Google what's the difference between cement and concrete, and I'll give an A+ if anybody knows the difference. Oh, well, we're gonna all learn that today, right? Well, after today and going forward, we'll always use the correct terminology. My kids now know, like they got it. And then talk about some of the modernization that's been done at this plant. And a lot of what we're gonna cover is really then how we meet our own Heidelberg Materials sustainability commitments. So real quick, for those of you who I haven't had the pleasure of meeting, so I'm Wendy Carl, I'm the Midwest Director of Environment and Sustainability for Heidelberg Materials. So I joined the company about 4.5 years ago. As I said, I'd never thought about a career in mining or cement. But after being in consulting for 19 years, which I've been at the same company for 19 years and really enjoyed it, but kind of was looking for some new challenges. I made the leap and here I am, and it's just been a wonderful experience ever since. If anybody is ever interested in a career in mining or cement, it's not too late. So we certainly welcome you. In addition to being part of sustainability, I also work with our Indiana section for the hazardous materials manager. So we welcome you. If you're not a CHMM, you don't have to be a CHMM to, I'm going to give a quick plug, to participate in our meetings, but we welcome you as part of that group as well. There's a few other of us, Michael and Paul and Mary and a few others who participate in that group. So we welcome you there. Also, I'm part of the Heidelberg Materials Employee Resource Group Network of Women. It's not a secret that there aren't a lot of us women in mining. If you go around to a lot of the quarries, you'll see it's probably, I should have that statistic. I'm going to put it at probably 95 to 98% men. But that's changing, and I certainly am trying to be part of that group that is changing that dynamic and changing the number. And it's not just women, we've got a lot of work to do on the diversity front. And, but I'm really excited that the company recognized that. We have commitments to KPIs towards increasing our diversity. They definitely, we hired a DEI director. We have now this employer resource group to identify what are the needs of our women in our industry. How do we attract more women? How do we keep more women? So I'm really proud to be part of that. We're working to improve those numbers. And also just recently joined the National Association of Women in Construction. Again, just trying to promote and bring women to our industry. So real quick,
Yeah, I do know some of you, but haven't had to meet most of you. I'm Michael Harding, as I said before, environmental manager here at the Mitchell Cement Plant. I'm a Purdue grad, but a Bloomington resident, so in enemy territory. It's fun, but we like it. Yeah, thank you. I worked for Wendy in consulting out of Purdue, so I spent 8 years in consulting before she dragged me over here into these events. And I've loved it ever since. Joined in December of 2021. Really had maybe a year and a half here at the old plants before we moved over to the new plant and started that up in April of 23. So got to see both sides of that. I'm also CHMM, and on the executive committee for the Indiana section. And by being the environmental manager here, I'm also a certified wastewater operator, just last ASO, and a certified landfill operator as well.
and he and I are going to be texting back and forth through a lot of our talks today. So hopefully you don't have to hear me drown on a lot, which I can totally do.
And real quick, I'll introduce in the back here, Scott Quast, in the beard. He's my predecessor and retired for almost a year now, which is hard to believe. But we had a lot of overlap here with the transition from the Oakland Chimney plant. So happy to have him back here today for this presentation, and he's going to help out on the tour as well. So, thanks, Scott.
So just a little bit about our company. So we have over 9,000 employees in North America. About 6,500 of that is in the United States. The remainder is in Canada. We're in 6 provinces in Canada and 28 states in the United States. Here in Indiana, we have 20 locations with 622 employees. We have 2 cement plants. We have a cement terminal. We have a slag plant and terminal, and then the remaining are limestone and sand and gravel quarries. We have a lot down in southern Indiana, few quarries kind of in central Indiana, and then a few up in northern Indiana. So what does our business look like? I'm going to stand up there so I can really see this. So you can kind of see the division of our business. We have we are the 2nd largest cement manufacturer in the world. We also have aggregate products. So aggregates are limestone. We say we take big rock and make it into small rock, and that's used in all kinds of construction projects that you'll see from roads to buildings. We also have concrete and asphalt operations. We do not have any of those here in the Midwest. But if you head outside of our region, we do have concrete and asphalt. And then we have some other services, kind of other revenue streams. One of that is we just acquired a company called SEPA, and that happened last year. And that is actually a proprietary operation that goes in and recovers coal ash and makes that into a cementitious product that can be used in a place of cement. So we're actually taking that waste. There's a lot of ash waste out there on Wash Pond. So we are able to recover that material and make it into a viable product. We also have slag plants. I mentioned we have one here in Indiana. We have one up in one in Ohio, which takes slag, also dries and grinds it and makes that into a product. So again, keeping waste out of the landfill and making it into a useful product. So I kind of mentioned here's our geographic footprint. We go where the limestone is, so, and where we can get it. So, you can kind of see where our operations are. Here's us here in the Midwest, and then we have our one outlier in Mason City, which is one of our cement operations. So we do have our sustainability commitments. So we focus on heavy building materials. That's what we do. We build the world, literally. So behind water, concrete is the second most abundant construction material on the planet. So what we do helps build the world. So, but as part of that, we recognize we have obligations to do that in a responsible way. So we have various commitments. We have wanted to generate 50% of our revenue from sustainable products. And our commitments are based on a 2030 timeline. We have a commitment to reduce our CO2 emissions by 50% by 2030, and that's based on 1990 standards. So when we talk about, this is mostly from our cement business line, when we talk about our CO2 reduction, we look at that on a kilogram per ton cementitious product, and we'll kind of talk about why we use that as our measurement. So we also have additional goals, specifically, as I mentioned, around improving our DEIA KPIs, and also around really engaging in our communities, and we'll kind of get into all of these various goals. With that, I'm going to actually, then we're going to kind of start here at Mitchell, and then Michael's going to talk about this plant, the cement process, and then also, then, like I said, we'll kind of just kick it back and forth today.
Yeah. So when you kind of stole a little bit of this. but-
Sorry, Michael.
We have a lengthy history here in Mitchell. When we were Lehigh Portland Cement Company and later Lehigh Cement Company, and now Heidelberg Materials. But there's been a plant here in Mitchell, a cement plant since 1902. And actually just right across the street here, in a big grassy kind of expansion where the first plant was. And so we call that plant one. Produced about 150,000 tons of cement every year, which was quite a big operation at that time for sure. Immediate success here in the Midwest in supplying cement to with the growing Midwestern cities, Chicago, Cincinnati, et cetera, led to plant two just 4 years later, commencing operations here. On this side of the road, just kind of that way, some remnants are still here of that plant. And they employed about 1,300 people, so it was a big, big operation. There was company housing, there was a hospital, there was a chapel. There was lots going on here, a big community for sure. And as Wendy mentioned, in 1928, Lehigh donated a significant amount of land, 258 acres to what was then the Indiana Department of Conservation, which became part of Spring Hill State Park. And so there's actually a cave. And it's called Hamer's Cave. Mill Creek comes up above ground at that point, and that was the cement plant's water supply, or the main water supply for years and years and years. We retained those water rights when we deeded that land, and we still retain those rights. We still use it as sort of a backup water supply, and you can visit it. There's kind of a sign plaque there and talks about our company and how we use the water. So it's pretty cool. Definitely echo when you get a chance. Check out Spring Hill State Park. So what we call Plant 3 then began operation in July of 1961 with 2 cement kilns. You can still see them out here. We will be at some point here in the next couple of years removing them, and we'll talk about why. What the impetus behind that is, but Plant 3 from July 1961 until April of last year. So definitely a long life for that cement plant. It was ready to go for sure, but it was kind of an impressive operation towards the end. It was one of the biggest operations through the 60s and 70s in the U.S. And toward the end of its life here, a good day was probably 2,000 tons of clinker, which is what produced out of the cement kiln. In comparison with the new plant, it's just one kiln, we're at 7,000 tons per day. So it's significant change, for the better in our capacity for clinker production, but just kind of for scale. So 2,000 tons a day, about 600,000 tons a year, or about 2 million tons with the new plant. Our quarry operations, we've had several kind of different quarry pits, but our main quarry pit that we use now. Started up in 1965. They added a third kiln to plant number 3 in 1972. And then in 77, the Lehigh Portland Cement Company was bought by Heidelberger Cement, which became Heidelberg Cement Group. So that's kind of where Heidelberg Materials comes in. So Lehigh was German owned from the 70s. And Heidelberg Cement had several different, I think over 70 different brand names throughout the world. And Lehigh Cement Company was the cement operations in North America for Heidelberg Cement. Until January of last year, everybody rebranded under one name, so it's less confusing now for sure. But we are Heidelberg Materials, all of the cement, aggregates, and concrete and asphalt business lines across the world. So we talked about the difference between cement and concrete. Here it is. Really good analogy. Cement is like the flour and concrete is like the bread. So remember that one. The cement is a very, very, very fine powder and actually makes it through sieves that water does not. That's how fine it is. And so cement is the chief ingredient and binder that goes to make concrete. So that's the simple answer. What is cement? Cement is the fine powder again that sets, hardens, and adheres to other materials. So in this case, in the case of concrete, it binds together the sand and gravel, construction aggregate, produces concrete. So hydraulic cements are cements that set in water, and Portland cement is the main hydraulic cement. So Portland product. And it's by far the most common type of cement in use. So almost all cement that you've ever seen or walked on or whatever is called Portland cement. And recently, the industry has made a shift from what we call ordinary Portland cement, or what we now call ordinary Portland cement, or type 1, over to Portland limestone cement, or which we call type 1L, PLC. I think one of you will talk about kind of how that change impacts our CO2 emissions on a per ton basis. But it's been a kind of long expected shift. And that shift was completed at this plant really in April of 2022. So it was really a big shift for the industry. Our PLC or type 1L main product is branded as EcoCem within Heidelberg Materials. That's the main product again that we produce here, but also we produce a type 3 cement, which is high release strength, used a lot in architectural applications, stuff needs to cure very quickly. We also produce a masonry cement, so it would be the mortar that holds building blocks like brick or stone together. So there's several different types of masonry cement that we make here as well. So the manufacturing process is simple, but also complex. And so simply we get the rock from a quarry, we grind it, we burn it, we dry it. That's simply, but as Wendy said, their cement starts with a limestone. It starts at a quarry. I don't know if this works.
It doesn't, everyone.
Not on the screen. Okay, I will point. So, limestone quarry, so dynamite blasting the limestone off of, what we call a high wall of the quarry. An excavator or a loader picks up the stone and puts it into a haul truck, and a haul truck takes it to a crushing plant. So typically there is a primary crusher and a secondary crusher. And we do have that, in our quarry. So you're sizing it down and then you're sizing it down again, for use in your grinding operations. So the limestone meets up with some secondary raw materials such as clay. We don't use sand in this plant, but this is just sort of an example. All that is proportioned and then sent into what we call the raw mill. For this grinding mill here. And so that grinds up our raw material into a very fine powder. And it's then sent into a preheater tower. Which as the material falls down, you have the hot gases from the cement kiln coming up the kiln and up the preheater tower. So that material makes contact with those hot gases. As it falls down, you have the countercurrent gases coming up. So it's a little bit like a heat exchanger in that regard. And so that material gets hotter as it falls down the preheater tower. And then it comes into a kiln where it finishes. And the product out of the kiln is called clinker. And so clinker is the chief, it's an intermediate product, but it's the chief ingredient in cement. So we store clinker in the big dome structure that you may have seen when you guys came in. And we'll definitely see on the tour. Very prominent, but we store our clinker in that dome. And then, I'm sorry, after it's cooled, it's stored in the clinker dome. And then we extract that clinker and put it into what we call our finish mill. So the finish mill is actually where the cement is made. We add a little bit more limestone. We add a little bit of synthetic gypsum, gypsum in general, but we here at the plant use synthetic gypsum, which is a byproduct of coal-fired power plants. So it's a coal combustion residual that is desulfurized and is gypsum. And so we buy that from coal-fired power plants and use that in our finish mills again to make cement. So that's finally cement is made. It is stored in some silos, which you can see out that way. We have a few more on the other side of the plant. And we load out our cements, again, very, very fine powder into trucks, 25-ton trucks, look like tankers, and also rail cars, which hold about 100 tons or so of cement. And so trucks come in here, we are our own distribution terminal, but we also distribute those rail cars really across the greater region for further distribution past our kind of local area here. This is the inside of the cement kiln. So you have your burner pipe going right in to the kiln, and you can see the material coming out of the kiln here, which is clinker. But pretty full view. You'll get to see hopefully how hot the cement kiln is. We'll walk by, hopefully very close if you guys are up to it. I know it's gonna be hot today, but you'll get a sense of how hot it is. But at the hottest point, it's about 2,000 degrees Fahrenheit, give or take. So pretty hot. And this is yours truly in the kiln during our last outage, a cold January day. So what you see behind you and what you can kind of see around the kiln is refractory brick, which provides a protective layer for the kiln shell because it's so hot inside. So in the background, I don't know if you can see it, but there are some men and there's a drill on top, and they're actually drilling that brick off to be replaced. So it's really loud in there, but kind of a rare opportunity. Really, we only have these kind of extended outages once a year in the winter. So I take my chance when I get it. But the burner, and hopefully we get a chance to see the back of the burner pipe today, sits basically right into where I'm standing. So I'm on that burner end of the kiln there. So this is what we now call plant 4. It's also called K4, which can stand for kiln 4. We had 3 kilns at the old plant, and so just logically, the next kiln was kiln 4. And so it's also the 4th iteration of the plants here in Mitchell. So all kind of ties together. As we mentioned, our quarry, we actually mine clay that we use in the system here at the Mitchell plant. It's the overburden at our limestone quarry. We actually didn't use our clay in the old plants, but we are able to use it in the new plant. So clay is probably 20% of our raw mix. Limestone is about 78% of our raw mix. So 98% of our raw materials into the raw or into the kiln we own on site, which makes production. It's a big advantage for production, I'll say. So all of these, so we have our limestone and our quarry. Our clay operations are kind of behind and around. All of that kind of comes up here into this proportioning equipment. And then is put into the vertical raw mill, which is kind of behind the preheater tower. We'll see that. And then the materials are brought up. There's a little storage silo that you can kind of see here. That's where we store the kiln feed out of the raw mill. Materials are brought up to the top of the tower and fall down the tower in a dual string. So one on the north side, one on the south side. And it's a stage 5 or 5-stage system. And it's basically just cyclones. And so the material kind of falls in as the gases come up, rotates around in the cyclone, and then falls down to stage 2 and does the same thing over, and then falls to stage 3, stage 4. There's a calciner burner out down at the bottom of the tower between stage 4 and stage 5 that does most of what we call the calcination, which is the removal of CO2 from the calcium carbonate in the limestone to make calcium oxide, which then becomes clinker. And so we'll talk a lot more about that, but that removal of CO2 is the big reason why the cement industry is very hard to decarbonize. So we'll talk about that, of course, and what we are planning to do to mitigate that. So the material as it makes its way down and then into the kiln, this is the clinker cooler here, and then it's conveyed up to the clinker storage dome and then extracted into the finish mills. We have finish mill number 5 and finish mill number 6 here where we make our cement. And then most of our cement is conveyed along this long conveyor and all the way right outside your window over to this side where we have our two new large cement storage silos and load out operations right on the rail line. So it makes a lot of sense for us to do that. So trucks go in there, so we have a big rail car operation where we load and transport rail cars. We also have a decently sized, but not as much of our business, but bag packing operation. And so 50-pound bags, I want to say, you can, at some stores like Lowe's, you can buy a bag of our cement if you ever wanted to. So the modernization project, we are kind of over here right now in this building. The old plant sits behind this storage building. You can see, just make out part of the old plant. But the new plant came together, I think they broke ground in October of 2018. Really, construction got going in 2019. Saw some pauses definitely with COVID, just the uncertainty of that, definitely some supply chain issues associated with that. But I think they started up construction again, maybe sooner than they thought. You know, the construction industry didn't really see a drop off like some other industries did. And so we got back going, and where startup, I think, was only delayed a few months, which was big. The old kilns were completely coal fired. And we are now 100% natural gas at this plant with hopefully some alternative fuels coming here in the next couple of years. But right now, 100% natural gas, so much cleaner burning fuel. It says we replaced 5 kilns in the Midwest with this one more modern, efficient kiln. So those 3 kilns out here in plant 3, but also 2 kilns down in our Speed, Indiana plant were idled. And so those, it's near Sellersburg down there by the river, and those kilns were also idled because of the production capacity of this new plant here in Mitchell. And that plant was converted into a slag plant, so it's in the process of being converted into slag plants currently. So the new plant compared to the old plant results in a 74 kilogram of CO2 per ton of cement improvement. That's mostly due to the natural gas component of the fuel. And this Mitchell modernization project was the largest, single largest investment that Heidelberg Materials in its 150+ year history ever made. So we're pretty excited and thrilled that happened right here in Indiana and right here in Mitchell. This is just some pictures of our plants or just our main equipment. So this is our vertical raw mill. So the technology is a rotating flat table. And then you have two large rollers that come down and grind against the table to grind the material. The material, as it's ground, if it's small enough, it raises and gets taken out by cyclone system. Again, simple, but complex ultimately. Of course, our pre-calciner tower. There's a picture of the kiln from the ground and one of our finished mills, which looks very, very similar to our raw mill. This is our main bag house, a little bit under construction, but it's a pretty massive bag house. We'll get to see it out there on the tour for sure. And then, like I mentioned, these large silos out here with this conveyor coming all the way from the old plant or from the new plant over to this old side for these new silos here. And a little bit of progress from start of construction on. So this was May of 2021, and you can kind of see the base here of what will be the clinker dome, the foundation of the cooler, and these are the kiln piers. So this is where the kiln sits now, and this is the foundation here for the big preheater tower. So that was May of 2021, about a little over a year in construction, or I guess 2 years in construction. But things really got going in 2021. Just a few months later, you can see the clinker dome is inflated, and if you're interested, you can go to our YouTube page and watch the inflation of the dome. It's actually really, really cool how they did it. It only took them maybe an hour and a half, 2 hours, really, to inflate the whole thing. And then on the inside, it's completely concrete, and they did that with shotcrete, so you're shooting concrete all up and down the inside of that dome, after the rebar was tied, of course, to support the infrastructure of that dome. It's a pretty cool storage facility, without a doubt. So from July 21 to December, you can see a lot more taking shape. And April then of 22, the following spring, we're getting near, at least physically, the plant being constructed. And by July of 22, really most of the infrastructure, the physical infrastructure was in place. But we did not start up until April 23 because there was a lot of other stuff besides just the physical equipment that had to go on before we started the cement plant. And definitely the most modern cement plant that exists in the US now. I should mention we're also the second largest cement plant in the US now, after one in Missouri. So this is Heidelberg Materials flagship plants, at least in North America, without a doubt. And then I think we skip ahead to fall 23 here. Just a nice picture of our fully operating cement plants. So we have lots of, I'll say, air quality regulations that we are subject to as a cement industry. And rightly so, but this is just some of the regulations that provide us with our, I guess, emission limits. So there's an ESHAP or max standard for the Portland cement industry. It's subpart LLL. And then we are subject, of course, as a new plant, to the new source performance standards at part 60 subpart F. A lot of our operations are also subject to the NSPS subpart LLO for non-metallic mineral processing plants, basically the before the raw mill process from the quarry up to the plant proper are subject to LLO. And then we have some PSD batch limits for NOx, CO, VOC, and greenhouse gases. We also have PSD avoidance limits for particulate matter. So what's going on in the air permit? And I just want to kind of compare the old plant limits to the new plant limits. Many of them became much more stringent. So for PM, filterable particulate matter, and a lot of these are on a pounds of pollutant per ton of clinker produced basis. But for PM, we were at 0.07 at the old plant and just 0.02 at the new plants. So baghouses have to be much more efficient. Total hydrocarbons, the limit stayed the same. For VOCs though, the old plant limit was at 0.3, we're down to 0.12 at the new plant. HCl was the same. SO2 and NOx is really where we see a lot of more stringent limits. SO2, we were 7.5 or so, NOx at 11.14. And those, along with the other ones with the asterisks, were purely PSD avoidance limits, or not, yeah, PSD avoidance limits. The new plant limits, of course, much lower, 7.5 down to 0.4 and 11.1 down to just 1.5 pounds per ton of clinker. So I'll talk a little bit about how we achieve that with some control technologies that we have in the new plant. And same with mercury, we're at 55 pounds per million ton of clinker down to 21. We also now have a greenhouse gases limit, of course, with the BACT at 0.97 pounds per ton of clinker for CO2. So we have a pretty robust continuous emissions monitoring system up on the stack, which you guys already see. So all of this we are required to continuously measure for. So we have particulate matter, total hydrocarbons, sulfur dioxide, which we also use as a surrogate for mercury. We measure our baghouse limit temperature as a surrogate for the formation of dioxins and furans in the baghouse, carbon monoxide, and then of course CO2. We do lots of stack emissions testing here. We have quite the initial stack testing program here. We tested our kiln, of course. We tested some of the finish mills, and then lots of the nuisance dust collectors around the plants. So an initial 3-hour method 9, just visible emissions, but for 3 hours required on 77 dust collectors as all new equipment. Initial particulate matter testing on 20 of those dust collectors. So a method 5 test. And then on the kiln, we had to do stack emissions testing for all of these pollutants here. Some of them I mentioned, but also beryllium, sulfuric acid, lead, and hydrogen sulfide that we have to repeat then every either 2.5 to 5 years, depending on which pollutant it is. But just a little bit more pictures of our stack testing that was conducted, I guess, in August, September timeframe, within our 180-day limit or window of when the kiln started up back in April of 23. So that's one of the nuisance dust collectors, and that's on the platform of our main stack at the top of the pre-heater tower. So I mentioned some of our controls. For NOx, we've implemented a SNCR, so selective non-catalytic reduction. So we inject 19% aqueous ammonia into the calciner, which is the bottom of the pre-heater tower, to reduce the NOx just to normal nitrogen and 2 and water within the flue gas. And cement plants are really sort of an ideal scenario for SNCR technologies, just based on the temperature profile. So if we need those higher temperatures at 1550 to 2000 degrees Fahrenheit for this reaction to really take place. And it does, of course. And so we have a large ammonia tank, which we'll point out on the tour, which is injected with compressed air and then just air lances within the calciner. And ideal molar ratio here is 1 part ammonia to 2 parts NOx. So that's kind of how we know how much ammonia to inject. And with SNCR, you typically see a 30 to 60% reduction in your NOx emissions. And really, we've done some measuring of ammonia out of our stack to see if there's any slip that gets through. We hardly see any. And when we do, it's when our inline raw mill is not running, and it's just very minimal. So that's SNCR. We also have a dry sorbent injection. to control for SO2 emissions. So we inject a hydrated lime, which is actually manufactured pretty similarly to cement, in that it is limestone that is put through a lime kiln. And so there's different types of lime, and lime is calcium oxide. This is a hydrated lime that we use to again, a very, very fine powder. We put it in with our kiln feed material at the top of the tower, but instead of falling down, it's finer even than our raw mix is. And so it kind of, as the gases come up the tower, the hydrated lime comes off and follows the gases down the backside of the tower. And then eventually makes its way into our flue gases, the baghouse. And so it interacts directly with the sulfur dioxide in the flue gas, as well as in the baghouse. To reduce SO2 emissions, and that below 350 temperature, again, is ideal. So that's kind of the back end of our gases, of our flue gases are quenched with water to cool them before they get to the baghouse. And so that kind of temperature profile is ideal for the hydrated lime control. And then activated carbon is a fine black powder to control, that we use to control mercury emissions. And so we inject that just before the baghouse. And so it actually coats the bags in the baghouse along with the dust, captures or absorbs the mercury. And then it's cleaned off along with the normal baghouse cleaning process, and is returned to the process. The way we purge that material is, and I'll talk about this too, is we reuse that dust within the kiln system, but also we purge it out into our finished nozzle, so it actually becomes part of the finished product. So yeah, so CKD is cement kiln dust, and it's actually an EPA special waste, and so EPA is very familiar with cement kiln dust. But it's just the filterable particulate matter that's collected by the baghouse, and it has cementitious properties because it has been through the kiln system. In the old kiln system, we pretty much all of the CKD that we produced as that byproduct out of the baghouse, we had to waste. We did not have anything to do with it. So as I mentioned, I'm a certified landfill operator. We have a still open CKD landfill just on the north side of our plant proper. That's lots of CKD there from the old plant over the years, of course. The new kiln system, no CKD is wasted at all, so we don't even have a way to waste it. So like I said, we return the CKD into the kiln system, where it actually is further, burned by the kiln and does become clinker. We also can purge that out of the system, like I said. This helps with a lot of our stack emissions, but especially mercury. When we purge that dust out of the system, it gets incorporated again with our cement and eventually into your concrete, so it's encapsulated. There's also some other beneficial reuses for CKD that other plants take advantage of, like a soil stabilizer and agricultural uses. So that's a lot on our air. And just quickly on some of our other environmental aspects here at the Mitchell plants. So I mentioned our CKD landfill. We are not depositing into it anymore, but it is still open currently. We have 8 outfalls that discharge stormwater and non-contact cooling water. So we have an individual NPDES permit with monthly and quarterly sampling requirements at all 8 of those outfalls. We do treat some water. Most of our processed water is non-contact cooling water that we do not need to treat. It doesn't get contaminated by anything. But we have an older CKD landfill kind of in the back of our current landfill, I'll call it, that has had some spring activity associated with it. And so that water that comes into contact with the CKD is a bit contaminated, and so it's high in pH. And so we capture that water before it's discharged. We pump it up into a treatment, just a small treatment facility that Mike here is designed so well. We bubble CO2 gas into it, and so just take that pH down into that 6 to 9 range where we are allowed to discharge into the creek. So because of that, certified wastewater operator and of course certified landfill operator. In the mining industry, we deal with wetlands quite a bit as far as, our mine planning, and mitigation when we expand our quarry into areas that, have wetlands associated with them. So that's something we deal with quite a bit. I mentioned our cool combustion residuals, our synthetic gypsum. There's also some bottom ash here at the plant that, was used in the old plant. So we store those coal combustion residuals here, and so there's regulations associated with that. We did have some underground storage tanks here at the old plant that were pulled in 2023, that were just kind of legacy fuel tanks. And then just being an older facility, we do have some PCB transformers on site. We've reduced that number significantly. I think there's only one left now. And then the old buildings were made with transite siding, which are asbestos containing materials. So another sort of thing that we get to deal with here. Break time? You guys have any questions on the process? I know I'm going through it.
I will just add, even though, we have landfill, honestly, like, we don't generate enough waste. Typically as a cement operation, we would normally be a very small quantity generator for house waste, and that would just be perhaps some maintenance products, maybe some, yeah, or maybe an expired product or so, but really, we don't have a lot that we have to, probably used oil would be the majority of what we would have to dispose of is used oil, maybe some oil contaminated debris, bulbs. We don't have a lot of battery things.
And the new plant's LED. That's what we want to do.
Yeah, like we don't really have a lot of aerosol cans, so really just as this particular operation, as a normal cement kiln, does not have a lot of waste or any kind of waste. I will just add that we do have our Logansport, facility, as I was trying to get, and that is the TSDF house waste burner. So that's its primary source of fuel. That's a whole separate beast. And if anybody's interested, we can get you a tour at that Logansport facility, but that is primarily fueled by HAZ and other, it does take non-house waste, but house waste is our primary fuel source up there.
But people are applying to send their waste there.
Yeah.
Pretty good.
Yeah. We also do take a lot of solvents up there. So many of you may take advantage of like a beneficial reuse of solvents. So those are actually taken to our Logansport cement plant to clean out heels of tanker trucks and rail cars. We can't ship back any heel or like a bottom buildup at the bottom of a rail car or a tanker truck. So we will use solvent that you all probably will use. It's for you now. It's still a product. It's still a usable product, even though you may not be able to use it in your plants. We will take that at our Logansport plant, clean out the tanker trucks, and then we will ultimately use that. Now we are the generator of that waste. Now it's on us, and then we will use that as fuel in our cement counts or cement in the port.
Not a process question. So there's lots and lots of limestone close to the surface here. But was it the plant cited because the constituents in the limestone matched those that you showed early in the presentation?
Yes, yeah, so back in 1902, right there, a lot of limestone in this area, but they chose the Mitchell plant, or the Mitchell area specifically because of some of the properties of the limestone, for sure. So they were looking at that even back then, and really, that's was the impetus for the large investment here in Mitchell, was again, the quality of the limestone here, but also the amount of reserves that we have, on the property that we own. We right now have more than 100 years of proven reserves of limestone, so that limestone will outlast even the life of this new plant.
And I think I recall Bedford is a location where, so some of the Indiana building limestone also comes from this neck of the woods.
It does. So there's an operation just north of Bedford and right off of 37 as you come down, called Indiana Limestone. And so it's in Oakland, it's the town just north of Bedford, and that's where a lot of the building limestone, stone blocks and stuff are produced there, that quarry.
But not all limestone's created equal. A lot of limestone not only would not be, doesn't have the properties needed for the cement process. Jeff can probably speak to it as well on the aggregate side as well. For, use for road base, building base, et cetera, or even to make concrete, you can't just take any limestone. That needs to have certain properties. And we also, any of these, and Jeff, because he did quality, Jeff is in operations at our aggregate plant before joining the environmental team. So he's just a fantastic resource when it comes to actually running an aggregate plant. But you have to pass certain DOT tests or DOT for roads, and then there's probably other specifications for buildings that you have to meet, that your limestone, like especially like freeze thaw, because we have a lot of that here in the Midwest, right? So there's certain parameters that your limestone would have to meet to be able to use as for construction material.
Why did clay in this space?
Why did we?
Yeah.
So cement manufacturing requires basically, a source of calcium, which is limestone, alumina, silica, and iron, a little bit of iron. And so the clay here is the silica and aluminum portion of that raw mix. And the old plants, I guess, the old plant wasn't necessarily equipped to handle clay. It's very, very thick, sticky kind of material. And so I think back then it wasn't as, we weren't able to use it as maybe we are now. And so in the old plant, we brought in sand, river sand, and shale to use the silica and alumina sources in the raw mix. And so the fact that now we have this clay here that we can use is, like I said, a big advantage for our process.
Your product that you produce out of here, how much does that fluctuate throughout the year? Can you talk to that?
So there's quality is a big part of our operations, and so we have a cement laboratory in our main office building that, again, you'll get to see. It's very, very important. And so we also have cross-belt analyzers coming into the process that tell us exactly what the chemistry is of the materials that are coming across that belt in real time. And so the control operators are able to make adjustments to, what materials, but also how much of those materials are used to ensure that consistent quality. And so it's a really, really big part of the operation. And so I would say it stays fairly consistent. Obviously, you'll have some kind of variation, and mostly that's seen at the customer side, as far as how long does it take to set. And that's kind of a lot of what people will do, what we hear back, and then we can make changes, more long-term changes based on that feedback.
It is, from a customer standpoint, it's very weather dependent.
Mhm.
One of the, as many of you have grown up here in India and Midwest, we've done see more mild winters. That's allowed for longer construction seasons. So that's definitely been helpful from our business standpoint. Certainly, we all recognize that's probably not how it should be, but it does help our business. Also, when it rains, you guys drive down roads, do you see construction going on in the rain when it's heavy rain? No, they can pour concrete when it's raining. It doesn't have a huge impact, but they just typically don't have that. So this has been a very wet spring for us, and we've definitely seen a drop in our business. So we like dry sunny days from a construction standpoint. And I will say that with the road construction, while we all hate driving in it, we love it. From an industry standpoint, I have to remind myself of that when I'm stuck on a 465 to 69 interchange, and I have to remind myself, we love this. But we do, so that also, so we are very dependent on customers, and a lot of those customers are highway projects. So we're also very dependent on federal government funding and also state funding for projects.
Can you store the product through those slower times and then have reserves for the construction season?
Yeah, so our two largest cement silos out here are 16,000 tons each, and We have our older cement silos, I think there's 30 of them and they're about 2,000 tons each. So that's our kind of storage capacity. And so we do, times like now, we're pretty low and we're fighting to keep those filled. Because, a week like this where it's been dry, sunny, great, this is peak shipping for us. And so we're fighting to keep those cement silos full. But over the winter, yeah, we have that storage capacity and we typically have a 4 or so week outage in the winter time. Obviously, it's very slow, kind of that mid-January to mid-late February timeframe. Shipping is slow, and so we're just relying on that inventory we built to get us through that, and then we'll produce it again.
And we stagger our outages, amongst our cement plants so that we, they're just a supply. Michael mentioned, we have a network of terminals. So we have 7, we're bringing on 2 more, strategically placed in the Midwest. And we are really able to leverage the rail infrastructure in the Midwest to get that cement to our terminals for then our customer pickup. We have added 2, so we did have 5, now we have 2 more specifically because of the capacity of this plant. We're able to reach further into the markets and we're bringing on 2 more as well to extend our markets and get that material out to their customers. But we do, between our cement plants, we stagger our outages to make sure that we, continually have a supply to the market. But we also do coordinate with we also know when outages are at other cement plants too. And, we'll do a little bit of collaborating to not have everyone. I don't know if you all remember, probably about 18 months ago, like nobody could get some, I don't know if anybody was trying to do projects. I mean, there was none in the market. And part of that was because it would be lovely to say you can flip a switch on a cement kiln and it just goes and it's all happy all day long. It is not. They are beasts. Even the new kiln has not yet. I mean, it's been operating a year. And again, you don't flip a switch and this thing's running perfectly. It has been up and down and up and down. And it's not just the kiln, right? You have to have the raw mill to be able to feed it. And, brand new, but anything has its struggles and you gotta get it fine tuned.
And honestly, the kiln itself is fantastic. It's the issues that we've encountered, and there have been many of them, are with the raw materials coming in and that equipment associated with it. Just one problem's fixed, another one comes, and it's just been, it's how a new cement plant apparently goes. What I've been told.
It's how an old cement plant goes too.
Yeah.
You have that midlife where it runs really well.
Exactly. But it's been a challenge, but, yeah, go ahead.
But we don't like to take kilns down, to get them to the temperatures and to get a kiln really operating at its peak performance. You want it to continue to go down. So once it's going, it goes 24/7, right? We don't want to take them down. So we try to very much time when we do have outages. We try to have this very well planned because that also gives us the opportunity to go in and do any other fixes we need. Because oftentimes you can't work on other wraparound pieces of equipment or things because of the temperatures. So you need to have that kiln down. So we do really try to plan those around kind of, again, it's seasonal when our other operations down. Sometimes they just go down because, something breaks. But yeah, we do have a lot of older, Michael was saying 1961, those kilns were running up until 2023, right? Or 2021. Three. We have our cement kiln in Mason City. It's from, the 1960s, right? So these are old, some of these are old and you just keep fixing them, keep working on it.
I just wanted to ask, because I think historically the Lehigh Portland cement kiln was accepting scrap tires as one of the fuels, and then there was some beneficial, the iron that came from the tires was added to the raw material stuff. I'm assuming that when you open the new plant, that's no longer an option anymore. Is that accurate?
So we did not do that at that plant. I don't know if they did that at Speed or Logansport.
No, they don't take scrap tires. There are plants that use it, but they actually use it typically more as a fuel.
Yeah.
The problem with tires is you actually, to really be introduced, it's about getting it into the system. That's the hardest part. So with tires, you do have to grind them up and kind of make it more of a fluff to get it introduced into the system. And even then it can kind of gunk up So, while there's an abundance of tires, we haven't really used that as a fuel source. We do look for other alternative fuels to burn at our Mason City cement plant. Which I'll talk about later. We operate about 25% seed corn, and we're looking at a project here to do this obsolete corn or soybeans too. Really, it's obsolete seed that we use. That also helps with our CO2 numbers. We'll talk about that. We're looking at other alternative fuels, but I think we do have one of our caliber material plants that is using tires.
Scott, we did do tires, we tried tires at some point in the last 15 years, maybe.
We didn't try tires, but as much as we investigated putting it mid-kill,
But just not successful or not, but
well, it's just, budget was the main thing, the tire supply wasn't there. It's the Evansville plant, in Pennsylvania, to have a tire system that.
Okay, there's one of these.
Good questions?
They were perfectly on schedule, like almost to the minute.
Good plan.
It'll take 15 minutes.
Yeah, I'm not gonna let.
But if your hours, it should be okay to have a little bit.
Real quick, sorry, I want to mention, I didn't mention before, there's a recycling bin over here, behind everybody, so. All we have is bottled water, but please, yeah, take advantage of that.
A couple of quick notes, I was talking, with somebody, just a few points on the project. As Michael said, that project was completed through a global pandemic. And, with the pandemic and then the supply chain issues that happened because of that, it really pushed the project back about 6 months. During the highest point of that construction project, we had 1,000 contractors here on site working. We had a lay down yard where the parts came. And I kept saying, I'm gonna see the bolts are gonna be left after this, right? Like putting together something from IKEA. So during that, we had 1,000 contractors here working, and we did not have a last name injury on the project. So definitely fantastic. A great achievement from that. We had a specific safety team dedicated solely to the project, in addition to our on-site safety manager. And just to give you a reference, that Michael, the largest investment in our company history, and that was about a $750 million investment right here in Mitchell, Indiana. We really helped keep the local economy going through COVID with the contractors that we had working here safely during that project. So thank you, Michael, for that very informative presentation about now everybody knows the difference between cement and concrete. You got it. So I'm going to focus on our sustainability commitments, which I talked about earlier. So we're going to dig a little deeper into some of these, specifically focusing on our CO2 initiatives. We're going to touch on our efforts on circular and resilient economy, safe and inclusive. I'm not going to go too much into that, but we do have some metrics around safety, and then also I think on our DEIA efforts, and talking about nature positive. We have a very large impact on the land, right? So we have a responsibility to do that in a sustainable way. So this kind of goes into, those are our 4-leaf clover of our sustainability commitments. And then within those, we have specific targets that we are going to meet up. Now I'm going to go into each of these individually. They are on our website if anybody wants to dig into them. And then we can make this presentation available as well. So we're going to go into a little bit. So sustainable revenue, we have a goal to achieve 50% of our revenue from sustainable products. And those sustainable revenue products can either be ones that are low carbon, and there is a definition as far as what a low carbon product would be, or circular. So circular would be things we do have, we can use recycled aggregate, right? So if we have aggregate that we have from other projects that we can take. Again, it's not as easy to do some of these because we have to get approvals to use our materials from DOT for other projects. You can't just take rock and put it in. So we are a little bit, encumbered by some of the specifications we have to meet. But we are trying to identify different projects, different ways we can achieve our goal, of our 50% of revenue offerings from sustainable products. So this kind of goes into, really when we're looking at, the overall life cycle of products. We're looking at, recycled content, reuse elements of materials, how we can reuse those. We're focusing a lot on, CO2, and we're gonna talk about that, but there's other, ways of actually utilizing CO2, that we're trying to investigate. So we can actually take CO2 and mineralize it into building materials. We have a lot of R&D into, how we can use some of the CO2 that we have. We also are looking at 3D printing and digitalization. So we had our first 3D printed concrete building and the EU. And then we'll talk a little bit more. We're going to dig into some of this, what we call clinker substitution, alternative fuels, and other ways that we're reducing our CO2 emissions. But before we kind of dig into that, so we're talking about biodiversity. So I had mentioned that, we have a big impact on the land. And so we have a commitment that each of our active quarries will dedicate 15% of their total space or their total acreage as space for nature. So we have our, a definition of what is included in that space for nature. If we have areas that are completely invaded, by a non-native invasive species, that doesn't count towards our 15% space for nature. So we're in the process of, and by the way, I should have started with our commitments, our sustainability commitments, really are in line with what the UN has put out as far as their commitments. So we kind of dovetail. We have other industry associations that were part of GCC and other industry associations, and that all kind of follows the global UN commitments. So that's where ours are coming from. So we're in the process right now of evaluating all of our sites. So we've gone out, we know our total acreage for each of our sites. And so now we are identifying which areas already have sites that, meet this 15% space for nature and which don't. 15% doesn't sound like a lot. In some areas like, Mitchell, some of our other quarries that are in maybe a more rural area or have a lot of land, that 15% is going to be fairly easy to achieve. But how many have driven up to Chicago and that quarry you drive over, right? That's ours, Thornton Quarry there. A lot of our quarries are in very urban areas and we use every inch of that space. We're trying to find 15% that we can actually use for space for nature is actually, it's a challenge. But we recognize that in order to promote enhanced biodiversity, that we have to meet these targets. So this is something that, again, right now we're getting our baseline, and then over the next 3 years, we'll be evaluating how to achieve these targets. Water. We have a lot of water that we have to manage in our plants. So when there's a few of our quarries that don't have as much water, but what happens when you dig a big hole? Can you imagine if you go outside and dig a big hole, what happens? Fill with water, right? So that's either going to be rainwater or just groundwater that seeps into the quarry. So some of our large sites. So Jeff, how much does Harding Street and Nonstop discharge?
8 million.
Pardon?
8 million gallons a day.
8 million gallons a day from our Harding Street quarry that we have to manage. So we not only have, discharge that water, we also use a lot of water. We use it for dust control on our roads. We use it for dust control on our piles. We also wash products. We have certain products that we actually will take in, we wash them. So we have to, so we recognize we have a big impact on local water systems. So there is we use a third-party company called BirdLife, and they've actually evaluated all of our sites to determine, basically rate them if they're in a low, high, or extremely high water stress area. And this, our sites that are in these high water stress areas have to develop a water management plan. And some of our sites go, I'm on a river. Why are we in a high water stress area? Doesn't, and actually look at the ones in the map, there's a lot up in the Chicagoland area, which are like, there's lakes there, there's rivers there. We've got sites that are up on Lake Erie that are high water stress areas. But water stress isn't necessarily meaning that there's a lack of water, it's a demand for water. So when you look at those urban areas, there's a high demand. I don't know if you guys remember Vince Griffin. Those old timers remember Vince Griffin. He did a presentation that whiskey's for drinking, water's for fighting, right? So certainly recognize that. And we've recently had some other water issues here, right? Indiana, those have been following. So water demand is certainly something that we recognize is important. And we have our obligation to evaluate and make sure we're managing our water in the most responsible way as we can. So community engagement. So all of our sites here in the Midwest have a community engagement plan. We recognize that, we live and work in our communities and we have a responsibility to do that in a way to engage our community. So we'd like to have our community engagement plans not just be, hey, it's great to sponsor a softball team. We really want to be out. We want to be engaging in our communities. Our employees live and work in the communities in which we, have our sites. But we also have an impact on our communities, right? We're impacting the land. We have truck traffic from our trucks. Sometimes we have dust issues. We try to keep it as best we can, but sometimes we do have a little bit. So we recognize that, we want to be a good partner with our communities. And we want that to represent our, our core values. So I talked some about our land use. I don't remember what I said on the slide. So I'm just gonna fast forward. Oh, I did want to bring out a specific project that I like when we're talking about our land use. So we have a quarry up in Romeoville, Illinois. It's in the Chicagoland area. And this quarry has this parcel called Middle Parcel. And on Middle Parcel, there is was a 6-acre rare wet Dolomite prairie. So this was a prairie that is regulated as a wetland. And again, it's rare, and the prairie exists on top of limestone. Well, what do we need in our business? Limestone, right? But not only was this a wetland, this area was also a habitat for an endangered Heinz emerald dragonfly, and that's our beautiful Heinz emerald dragonfly right there, which is a federally listed endangered species. This area was also, and it's a habitat, not a breeding ground. It's a habitat, so basically land that's traveling to their breeding ground. And this dragonfly likes very wet areas. It actually, that's where it breeds and makes these little rivulets in very wet areas, but again, not breeding ground, just habitat. There are also state listed landings and spotted turtles on this 6 acres here, as well as 2 other plant species. There was I'm forgetting 2 other state listed species here. So we need to get access. There are a lot of reserves there that we need to wanted to get access to. So, here we go, spotted turtle, there's the endangered leafy prairie clover, thank you, and then the lakeside daisy. So these are the covered species that were on this rare habitat that was on top of these areas that we wanted to mine. So we spent 20 years working with the U.S. Army Corps of Engineers, the federal EPA, the, Illinois EPA, and also, Fish and Wildlife Services, thank you. That it took 20 years to get a permit, to be able, well, there's multiple permits, right? To make this whole project come together. So overall, we would be impacting, 50 acres of Heinz Emerald Dragonfly habitat. And in order to, mitigate for that, we actually, are permanently protecting 519 acres elsewhere, along other parcels that we either owned or purchased. We restored 354 acres, of habitat in that area. And by doing that, we actually are connecting, kind of making a corridor for this, dragonfly, to actually get kind of from where they are known to other areas. So we're kind of increasing their corridor. So by all this, we should increase the known adult Heinz Emerald Dragonfly habitat in all of Illinois by almost 12%. So a fantastic project there. And then again, we're are rescuing 6 acres of this wet basic delimited prairie. So, one of the issues with the prairie is that, and I'm actually just gonna fast forward so it's a little easier to see. You can see, so here's our prairie, right? In this middle here is this beautiful prairie, so, you know, got this gray area. Well, right here, there, and you can actually see it kind of further in the back, there is a very, non-native invasive species called Phragmites. Once you see Phragmites, like it's like honeysuckle, right? Those of you who know what honeysuckle is, you just see it everywhere now. Once you see Phragmites, you will see it everywhere now, especially up in northern Indiana, over in the Chicagoland area. It's a water loving species as well, as is our wet delimited prairie. But Phragmites is a very reedy species, and it will come in and take over. And I mean, to try to even get, you almost need, you know, a stick or something to just walk through this stuff. So you can see this wall of Phragmites that's encroaching on our rare wet delimited prairie. Well, then on the other side, on this background, there's a woody brush plant, kind of a brush tree, buckthorn, which is another non-native invasive species. So this entire prairie is completely being encroached on by 2 non-native invasives, and left to do nothing, this actual prairie would have been destroyed and taken over by these non-native invasives. And unfortunately, one of the things that happened, here's just some other pictures, you can really close see that buckthorn coming in, and then you even see the Phragmites popping up. But unfortunately, one of the things that happened is because it took 20 years to get the permit, you can see the encroachment of the buckthorn and the other species. This was in 1996. This area was the prairie. And then what happened in 2017, you can see how much the non-native invasives had taken over. So we had a lot of community pushback on our project, right? They're like, you're wanting to take, you're gonna have an impact on the Heinz Emerald Dragonfly, you're gonna have an impact on this prairie. And we kept saying, yeah, but if we do nothing, it's going to be gone, right? And so that was a big challenge. And, you know, we talk about community engagement, and we spent a lot of time working with the community. We invited them out, like, come look at the project, come see what we're doing. And when we did, we got a lot of people understood it better. So what did you do, Wendy? Well, what we did is we moved it. We actually took the prairie and so it took 20 years. We got our permits. And then in January, we were able to move this prairie. So what we did is we basically cut it, went in, they mapped the whole prairie. We had, let's see if I've got a better shot here. No, take it back. Here we go. We basically, around this area called River Parcel, we actually prepped an area went in, that was already had a lot of non-native invasives. We cleared it, we did some fires and prepped it because we did test parcels on this before as well. So it wasn't like we just went in and thought, we're just gonna move this prairie, it's gonna be fine, right? No, we did a lot of tests. We did a lot of hydrology studies, on this and, we found an area where we think this prairie is gonna work, right? So we mapped the 6 acres of prairie. We cut it and we scooped it up and we moved the whole thing. Took about 6 weeks to do it. They kind of at first thought they were just gonna like scoop it up and then, like take the plot and put it on a truck and they piled it up and moved it over. That didn't work so well. What they figured out what did work is they actually moved the scoops. So they got more scoops. They scooped it up and put the scoop on trucks. So they took up this 10 scoops and then with a little bobcat. And then they had another bobcat over at the receiving site and they took it over and took the scoops off and then they laid it down. And it was just a patchwork and they identified some areas, were like this big, some were a little bit more this big. And so they mapped it and tried to piece it all back to where it was and then fill in the gaps, took dirt from that site, hoping some other seeds and things in there and fill all dirt and then you kind of just push it down. So now we are, so this whole area is now permanently protected, this corridor here. And we're now starting to enter our monitoring phase, right? So now we have to prove that this project is gonna work. Again, after 20 years of working on this, having, biologists, having hydrologists work on this project, we're fairly certain it'll work. So, we're putting together some information that we'll put out on our, LinkedIn page about this project, and then hopefully I'll be able to report back and kind of show you the fruits of our efforts. So, again, not only do we recognize that we have a commitment to the areas that we are, mining our materials, we, try to do it the best way we can. So just an interesting project. A lot of effort. So I just threw this one in here. So we have an initiative through our worldwide organization. This is actually a plug. This is a shameless plug here. So we have a worldwide initiative called the Quarry Life Awards. So anyone outside of our organization, any of you who have an interest in doing a project on any of our extraction sites can come and work with us and do your project. So this could be any kind of project, right? Maybe we're working on a habitat restoration project. Maybe we're finding a different use for some of our other materials that we can't use. Well, I said don't generate a lot of waste. That's kind of the typical waste you think like hazardous waste. But we do have what we call overburden, which is, you have to clear off material to get to the rock you need, and we can't use all the rock. So maybe there's some other use that we could do. Maybe there's a study that we could do at any of our quarries. And so there are prizes that go along with the Quarry Life Awards, and then actually the ceremony is usually at a very cool place in Europe. I'm not sure where this next one is going to be. The last one, Jane Goodall was actually the presenter to the recipient of the last Quarry Life Award. So if any of you have a product, prizes up to 30,000 euro for, so if anybody has a project they could think of, you'd want to do at any of our quarries, doesn't have to be the special plant, any of our ones here in Indiana, you're welcome to come talk to us about it. Sure. Oh, here we go. So the focus of it is around biodiversity, habitat, and species research. Again, maybe creative solutions for our use of our products in other ways. So there's 4,000 for the first prize, 2,000 for second, 1,000 for third, and there's kind of in these different streams gets to the 30,000. Okay, but so a lot of what we want to talk about is our CO2 initiatives. So we have a goal as a company to reduce our scope 1 CO2 emissions from, to 400 kilograms per ton of cementitious material. And that is from our 1990 baseline. So, we have various levers that we pull to try to meet that goal. And this is global, not just here in the Midwest. This is all kind of rolling up to get to our global reduction target. So, now I'm gonna sneak through this slide here. We do have other, I'm sorry, script two. My apologies. So we also have a goal of reducing our scope 2 emissions by 65%. So for just as a quick, for those who aren't familiar, scope 1, scope 2, scope 3. Scope 1 are emissions from our actual process. So from in this case, it would be our kiln operations or any of our, really to make our cement project, our product, that would be our scope 1. Scope 2 are energy, so primarily electricity use. So we have a goal of reducing our scope 2 emissions by 65%, based on 2019, to by 2030. And then scope 3 are really things that are kind of outside of our direct manufacturing operations. A lot of ours are going to be around transportation. So that's going to be a lot of it would be our customer trucks and transporting our cement products from our sites, and other things in our value chain, and that would include even, you know, how we receive our raw materials as well. So we have a goal of reducing our scope 3 emissions by 25%. And those are a little bit tougher to meet because we don't have direct control over scope 3 emissions, right? So that's going to go out to our customers and to other people in our value chain to try to work with them on how they're reducing their emissions. So kind of digging into how we are achieving our goal, we talked a little bit about the clinker incorporation, and I've got that another slide. So there's multiple ways we're going to achieve that goal. One is through our clinker incorporation, the plant modernization and alternative fuels. We just talked a little bit about alternative fuels, and I'll dive into that a little bit more. But then the last lever that really we're pulling, especially here at Mitchell Plant, is carbon capture and sequestration. So I'll show you into that. So kind of how we got, now this is down specific to the Midwest. So our Midwest baseline was 826 kilograms CO2 per ton cement in 2019. Our roadmap without carbon capture has us down to 543 kilograms by 2030. So certainly overall an improvement. We did that here at the Mitchell K4 plant. We reduced by 96 kilograms specific to the Mitchell plant on a per ton cementitious just by switching to natural gas and just a more modern, efficient plant. Michael talked about the Portland limestone cement. This was a really great project that we like to highlight because we actually had stretching out incrementally increasing our Portland limestone cement product that we get them out to 2030. And so I think Michael had mentioned that the PLC, the way it works is we take our clinker, we grind it as a gypsum to make the cement product. Well, we actually will grind limestone and add that to this finished product. By adding limestone to the finished product, we need less clinker. Clinker is the heavy intensive where we get our CO2 emissions. So if you need less clinker on a per ton cement basis, that's what we measured on a per ton cement, right? It doesn't you do overall impact your CO2 emissions because you're making less of it. But when you are trying to kind of do apples to apples, it's really on a per ton, how much cement you're making. So by adding more limestone, you reduce the amount of clinker you need, overall reducing your CO2 emissions. So we had a plan to roll out this PLC product up to where we were fully into 2030, but it went so well. Customers were on board. We actually did this conversion in 2 years. all our plants went to this in 2 years. Now, I will say it took 20 years in the making because we had to get DOTs on board that we could make this switch. That's a lot of our struggle is to get the market to lead efforts, right? If there's no market for any of our products, we can't get it out, you know, there's no point of making it, right? So we gotta get the market to help drive some of our initiative. So yeah, it took 20 years to get the DOTs to go, okay, we'll take your PLP product and put in figures too. So really great story. It performed well. Was it all 100% great? No, I mean, you had to work with some customers because the application, and that's not my specialty, had to be language was slightly different than what they were used to. But once they became familiar with their product, it worked great. And so they were like, yeah, okay, let's do this. So we do also have, I mentioned earlier, we have 2 slag cement plants here in the Midwest. One just came on board. The plant Michael mentioned themselves right at the beginning. I used to be a cement plant. We idled those kilns, brought the production here, converted that over. They just put in their slag dryer a few weeks ago. So now they will be taking a product, the slag product that normally would have gone to a landfill. They are drying it, grinding it, because it's a less fuel intensive operation. It's much more sustainable because it's a lot lower CO2 emissions to get that cementitious product out into the market. So that helps towards our overall goal. When you're looking at our volume cement in the market, it's less CO2 intensive. And then Michael mentioned that cement kiln dust. Our Mason City, Iowa plant does sell cement kiln dust. They used to waste it into their landfill, but they actually sell it now. It's a really good soil stabilizer. It's used a lot for wind turbines, when you're constructing wind turbines. So that diverts over 14,000 tons of that cement kiln dust from the landfill to use. I will also say that Mason City cement plant is powered on 48% wind energy. Many of you are familiar with Northern Iowa, there's a lot of wind turbines. So really helping our scope 2 emissions by powering that 48% plant. And then alternative fuels. So the Mason City plant I mentioned earlier runs at about 25% obsolete seed that diverts 45,000 tons of seed from landfill. And also helps to reduce our CO2 emissions because it's a higher biogenic content. We actually are able to take credit for that towards our CO2 emissions. We're looking to expand alternative fuels and use that in other places. Like we said here, we're going to try to use corn. There's other materials that can be used as alternative fuels. There's and I'm familiar with the non-hazardous secondary materials rules. But basically we can take products, we have a supplier that takes and make this resource derived fuel. It's kind of like plastics, papers, cardboard that they size, make sure it's this nice great material and we can burn it. The regulatory mechanism for doing that is very complex. So we can't just take and burn anything. Otherwise we would be a solid waste incinerator and subject to this whole other set of very complex rules, which we don't want to do. So we have to be very mindful of the regulatory world in which we live in to do this, but also EPA needs to catch up with us too, without getting down into the weeds in that. We would love to be able to do this. We're diverting this material from landfill. We actually would be reducing our CO2, but the regulatory mechanism for us to be able to do that is very outdated and it's challenging for us to make this work. So anyway, that's a whole different talk. So how do we get to that 543? I kind of told you our story about our Portland limestone cement. That project reduced us by, sort of showed a 46 kilogram per ton improvement. A great product there. Talked about our slag drying, that had 33 kilogram per ton improvement. Our alternative fuels was 26 kilograms. So when we get to our cement manufacturing process, Michael kind of talked about the calcination process where we're converting limestone, going from that calcium carbonate to calcium oxide. And when you do that, you emit CO2. So that's just our primary process. And when you look at that, different slide. No, I guess I don't. So this process itself is responsible for about 75% of our CO2 emissions. Doesn't come from fuel. It comes from the actual calcination of the limestone. So we've already done a great improvement, right? We switched from coal to natural gas. Great job there. We could say, well, can't you electrify your kilns and not use natural gas at all? There isn't technology out there right now that's proven to meet the energy demands of a kiln to electrify it. So, okay, well, and even then, again, we could electrify the kilns, but we're still left with just the calcination process. And there isn't anything that we can do to mitigate that. So, we've looked for alternative markets for CO2 as a product. There are some available. There's really not a market to take off the volume of CO2 that we have, but we're still looking for those outlets. Again, I talked about equipment electrification, but that still leaves us with what do we do? Well, that's where we get into carbon capture and sequestration. So we're looking at this globally for carbon capture. Right now, our plant in Edmonton, Canada, is a little bit further along. They actually have been working on their test study right now to capture CO2 using an amine-based system. And their goal is to store 1 million tons of CO2. So up in the Alberta, Canada area, there's actually a kind of a hub for storing CO2 that multiple companies are looking to store CO2 in kind of this storage hub. So right now they're hoping to have their test study completed this year and then perhaps start commissioning in 2026 if this is proven now. So they're hoping to be the world's first full-scale carbon neutral cement plant in Canada. So here at Mitchell, our goal is to be the first carbon neutral cement plant in the United States. So that means storing 2 million tons of CO2 a year is what we believe we can store right here below our Mitchell, Indiana plant. So it is extremely unusual to be able to store CO2 right underneath where you're generating, but we happen to be sitting on a geology that we believe is perfect to store this CO2. We are also using the same technology that Edmonton is looking at, which is an amine-based technology. The budget to do that, to the estimated budget to construct a carbon capture and sequestration system is over $1 billion. It's a pretty big price tag. Considering that brand new plant out there costs $750 million. And by the way, by the time we actually start construction, well, I'm sure in 5-6 years, hopefully we'll be over, that price tag will go up. So I'm going to tell you where we are on our journey towards carbon capture. So we have 4 awards because how do you do $1 billion? That's hard to do as an industry. Right now, we don't have a scheme in the US to help offset this. We don't have a carbon tax credit, right? So it's tough for industries to say, well, we're just going to put the budget, fit the bill for this out of the goodness of our heart. Well, we recognize that the cement industry is responsible for 6% of the global CO2 emissions. And we have a responsibility to reduce that. That's hard to do at $1 billion price tag. So we have been able to take advantage of the Department of Energy has grants from the Department of Energy. So we have 4 grants that we're operating under now from the Department of Energy. The first is a FEED study. So that is where we're actually working with an engineering firm, Sargent and Lundy, using the Mitsubishi Heavy Industries amine solvent technology. So right now we're engineering and designing this project. So this has an 18-month project. It's a cost share of 80-20 from the Department of Energy and Heidelberg Materials to help fund this project. And these are kind of the statement of project objectives, where we're looking at the, project management. Then here we have really the engineering, which is the bulk of the project. But we do have to have a business case as part of that. Again, how is this going to be funded long-term? A big component of that is really on environmental justice. And I'm going to talk about that as well. So this is the engineering study. So we launched this really full steam ahead probably in August of last year. So, early 2020, where are we now? Early in 2025, we should be wrapping up the engineering study for our carbon capture system. So here's kind of a flow diagram of what this system looks like. You can't just take, we don't just take the flue gas and inject it into the ground, right? Our flue gas has a lot of other components to it. It's not all just CO2. There's many other things. And actually, you have to have it as a pretty pure CO2. We have to take out some of the other pollutants because we'll actually damage the immune system, especially NOx and SO2. So in addition to the control technologies Michael mentioned earlier, it's likely we're going to have to add additional controls to get even the low amount of NOx and SO2 that we are emitting down even further. So it's probably going to mean a scrubber that will have that on there, because otherwise it will degrade that that solvent that we're using. So we have our flue gas, which is likely already gone through a scrubber that's being identified now in the engineering study. So the flue gas is quenched. So we have to get that cool exhaust down to about 113 degrees Fahrenheit or below. So here, I'm trying to see them in a little bit of a weird angle. So here we have a stack that's going into the quench system. The exhaust gas then enters at the bottom of the absorber tower. And here's where it comes on, the magic happens. Here's where it comes in contact to this amine solvent. Treated flue gas, then the remainder of the gas actually then exhausts here. Here then we have the CO2 rich solvent that comes out here to the regenerator tower. So here then in the regenerator tower, it's cooled and the CO2 then is pulled off into what's called a supercritical fluid. So it's really kind of this compressed CO2 in a, again, it's called a supercritical fluid. I don't know how else to describe it. I've not actually seen what it looks like. So we pull this pure CO2 out. So at this point, you're about 99.9% pure CO2. Then the amine solvent actually comes back through a regenerative system and is used again. So we're not generating a lot of waste solvent. There may be times where we have to do some replenishing, but there shouldn't be a lot of waste solvent from this process. So then we're able to now inject this supercritical fluid. We have to do a lot. We have to do a lot as part of the engineering study. We had to do very specific stack testing for the engineers to be able to design this system. We couldn't just go out and hire any stack testing company to test for the pollutants at the levels that we needed them to test out. So we completed that testing last fall, and that's informing the engineering that is being done now. This is kind of just some additional information about that testing. So the second grant that we're working on is the storage piece of it. So we're actually not the primary recipient of that grant. The Illinois State Geological Survey is the prime. So the ISGS works out at the University of Illinois, and the ISGS is really one of the leaders in geological storage right now. We are working at the Indiana State Geological and Water Survey. Bloomington is also participating in the project, but really the ISGS kind of are the leaders almost nationally in, geological storage. I'm gonna talk about that project. So, that's also an 80-20 cost share for, that site characterization. So we are hoping, this has been taken on, so a lot of red tape and a lot of paperwork when you're working with the Department of Energy on grants. So that one actually, the award was announced over a year ago. We are just getting to the point where, we're able to really move forward. So what we're hoping to start now in Q3 is a geological study. So we'll be drilling a test well here on our property, and it will be going over 7,000 feet down to study the geology. We believe that, so here's the pad for the test well. You can see us, we're all the way back here. There's our tower. There's the pad for the test well. We've been ready, so we're just kind of waiting on some of the kind of final paperwork, so we can pay the contractor, the subcontractors, all of us to do this study. So, we are hoping to start this in Q3. And, here's kind of what this will look like. So again, we are really sitting on just this prime spot where we think the geology will be able to store it. You can't just store this CO2 anywhere safely and securely. So what we're trying to do is, we believe, based on known geology, that we've got formations, and I'm not a geologist. I'm just trying to learn as I'm going on this. But are you geology?
Close, but not.
Okay. So what we're trying to do is we're targeting sandstone layer. So sandstone is a very porous and permeable formation. So porous meaning lots of little holes that will also allow, that will absorb the supercritical fluid, and also will allow the fluid to move out through it. Now, right now, those little holes are all filled with what's called a saline aquifer. So there's a saline aquifer that's existing now in this porous permeable sandstone layer. So we're going to be injecting CO2 down into this porous and permeable layer, and it's going to push out some of that that saline aquifer. That entire area that we're targeting, where the pressure is going, pushing out that aquifer, that whole thing's called the area of review. And all of this information we are pulling together to inform ultimately the permit that we're going to be applying for the EPA to be able to do this. But you can't just, and the nice thing about this porous permeable, it will absorb this CO2 and lock it in place. But that's not good enough. You also need an impermeable geological feature above it. And we believe that we have shale above our sandstone layers that will lock in this CO2. So we had the opportunity to go over to the ISGS at the University of Illinois. They were having this full day open house. And again, not being a geologist, I'm talking to these geology guys, and they're like, so kind of walk me through what does this look like. And so if you happen to have some sandstone and you have he poured some water on the sandstone, and you can see it there. He poured some water on the shale and kind of went off a little bit. And then we started talking. And a few minutes later, I looked back, and you can see the wet spot where the water had stayed on that sandstone. It was not on the shale. It was gone. It either evaporated or rolled off. I mean, it like literally it's just not there at all. And that's what that shale does. In this case, the water, but in our case, that supercritical CO2 fluid go through. So when we're looking at it, this would kind of be a rough outline of what injection would look like. So we would have our injection well here on site. 1, maybe 2 wells is what we will look at, depending on how many formations we're targeting for storage. They would be over a mile, probably likely between 4,500 to 6,000 feet below surface. One of the concerns we've heard from other communities is like, well, we're concerned about this contaminating our groundwater. Well, again, we're targeting those porous geologic features where to absorb it over an impermeable layer 6,000 feet below where we would have drinking water wells. So then we know about what a drinking water well is. About 140 feet. Yeah, so we're thousands of feet below where, and again, this is CO2, right? Who's got a soda? You're drinking, you're drinking it, right? These are not, this is not toxic chemicals that we're talking about as well. When we're looking at storage. So, again, this is kind of going into some of those geologic, features. So it's really not, it's our project here down in southern Indiana. But, many of you may have heard, if you're familiar at all with, kind of the carbon storage right now, we're from Decatur, Illinois. That's where they have, some carbon, storage, a lot of carbon storage going on. Other companies really at that side of this region are having to look to pipeline their CO2 when they're wanting to do storage. Fortunately, we would not have to do that. So, here kind of gives you an idea of the formations that we're looking at. So we're kind of targeting this Mount Simon here, which has this Eau Claire shale layer above it. So that's one of the areas that we're targeting. We may be looking at the New Richmond as well. So that's for these geology guys to figure out if they're doing this study. But it's actually really, we have many geologists who want to kind of see this because drilling down to over 7,000 feet is not something that's done often. So we're excited to even just the study that will be happening, will be exciting for a lot of people in the area. So we actually launched last summer. We weren't able to drill yet. We got special permission to use some of the funds to do a 2D seismic study. So, what that was is we did about 53 linear miles of a 2D seismic study. So what it was is we went and took these the people who did this, not me, took these transponders and put them in the right of way along 53 linear miles of road. And then they used this, kind of like a dumper truck. So at the bottom of this truck would drive every 40 feet or so and put vibrations, these vibrations down into the ground. It was picked up by these transponders. And so all this data that was collected, and what we're trying to identify is looking for faults. So there is it's called the Mount Carmel fault. And people have heard about, we have earthquakes down in this area. Well, that's what we're trying to identify, where these potential faults are in this area. Because again, when we're gathering information for our permitting, just demonstrate that we can safely store the CO2. That's part of the project that we're doing. So this was really cool. They brought back this data, and I was on some of these calls, and they come up. Oh, wow. This looks like an ultrasound. I have no idea what I'm looking at here, but it was really informative to these geologists out here. So that took place last summer. So overall for our project, this was the old town. We are I think we're right in here. I think we're right there at that building. The test pad I showed you is over here. So that's where we're doing the geological testing. If I did mention, I think I said we're looking at storing 2 million tons of CO2 a year. At this point, we believe we have more than 30 years capacity to store safely below our property. In Indiana, as the rules are currently written, you own the pore space below your land. So we own all, the pore space to do that below ours. If we were to go outside of our property bounds, and we have, just got 2,500 acres, 3,000 acres here?
Just slide 3,000, yes.
Okay, so just like 3,000 acres here, if we were to extend beyond our property bounds, we would need to lease. And that's what other companies have to do as well, is they have to work with local landowners to lease their, the pore space below to do the storage. There's a lot of, we're participating in the Indiana carbon rulemaking work group that's working on this. There's already rules in place for a trust fund. So we will pay 7 cents a ton of carbon stored towards an Indiana trust fund. That ultimately would be managed by the state for future liability, kind of like Lust, right? You guys are maybe familiar with the Lust. For UST, this is a similar carbon trust fund. We're also, I think I talked about permitting, so I won't jump ahead yet. So this is our new plant. We will walk past maybe our old plant here. So our old plant would be decommissioned completely, torn down, demoed, and the carbon capture system would go where that old plant is, with some ancillary, equipment, cooling water, other support equipment, just to the north. East, thank you, Sam. Isn't that great? So, the third, Department of Energy grant that we're working under, is really what we're kind of calling this demonstration project. So this really ties the capture piece, the storage piece, all together. This also includes, this section includes permitting and also, a very extensive community benefits plan, which includes job training. And then we are very, very excited. Oh, you're gonna update this slide. Just about 2 months ago, it was announced that we've been selected for a $500 million grant for the Department of Energy towards construction. So leaves us with over a $500 million price tag, but really this project would not be viable without the support of the government to help fund this. So yes, we were selected for the maximum award, which was $500 million. We are still working through the negotiation phase, so we can't really say we're awarded it, we're selected. It's a little bit confusing there, but very excited. This really does help support the project. But, we're also taking on a lot of risk. We are still putting $500 million towards that project. But, we believe this is the right thing to do to help decarbonize, the cement industry. And that's why we're committed to doing this. We still need some help from, the market, right? Because we need people, it's still will increase the cost of our cement, right? So this is gonna be at a market premium. So, when we're hearing from, these, Amazons, Metas, these large data centers, they are indicating that they want to have, low embodied carbon construction materials building their buildings, those types of the markets are the ones that we're gonna be looking to be paying this for this premium cement. So kind of where we are from a permitting standpoint, we did receive a permit from IDNR for our test well. That was a process in and of itself because there aren't a lot of these out there, even though all we're doing is drilling just to check the geology, right? We're not storing CO2 at this point. This is just to do a geological study. Sure, we were the first. And so one of being the first does come with some challenges. The part of the project will be gathering information for any air permit application. So likely that's going to take us about a year just to collect all the information. Once the engineering is complete on the capture system, to submit an application. We've already talked to IDEM, like, hey, how long do you think this will take us to even get an air permit? We're probably looking at 18 months to get an air permit from IDEM, and that's not enough. We have to do any modeling. But then we have the bigger piece, which is the Class VI injection well. So EPA is regulating the CO2 storage. There's only a couple states that said that they are going to pursue primacy, meaning they would be the permitting authority. Indiana said we are not pursuing primacy. However, we're going to give you our own permit. We will have to prepare. Basically, the application is pretty much the same as the Class VI permit. Just Indiana's going to kind of have their own permit. So this is really what that permitting timeline looks like from an EPA perspective. So we submit the application. We're kind of in this pre-construction phase. Then you get your permit to construct. So then you can construct, but you can't inject. So you construct, you finalize your site characterization and report back all of your information from your construction to the EPA. Then you get your authorization to inject. Then you can start injecting. See my slides here. Now, where we are with, IDNR, as far as their process, when IDNR first was, and IDNR in Indiana, not IDEM, will be the permitting authority for, Indiana. They wanted us to submit an application after we got your authorization to inject. We're like, we've already spent $1 billion. We're ready to go. And now you're wanting an application then, like, that's not gonna really work. And but again, they brought industry in to, participate in this rulemaking process. And so we were able to get them to like, go, oh, okay, yeah, we got it. So, they've adjusted their timelines to kind of a little bit, coincide. It's not as great as we would want, but that's okay. It's better than what it was. We're still working on what the fees look like to help fund this whole program. Right now, it's taking over 2 years for, this process to take place, at the EPA level. And that was with the projects they already had in the pipeline. EPA actually has a website you can go to and track all these projects and where they are. And they actually issue a permit for each well, not on project specific. So if you have multiple wells, you get a permit for each well and not for your project. So if you see out there that they've issued, I think right now there's only 6 actual permits that they've issued for 6 wells. That was my last check, but it's been a couple months ago. And I think there's right now, I think only 2 or 3 are actually moving at this point. Some of you has anyone heard about Wabash Valley Resources? Wabash Valley Resources has a project not too far from here, and there's been a lot of community pushback because people, need to understand that this is safe. That this, while this seems new and is becoming more prevalent, injection has been done for a long time, and CO2 has been injected safely for a long time. Just north here in Lawrence County, they inject natural gas and it's stored for various use, right? So we're already doing injection for other materials. Again, it's, the safety of this has been proven. So we've actually been really trying to partner with other industries who are looking to do carbon sequestration in Indiana. We're looking at, we've been talking a lot with Duke Energy. So they are actually our energy provider here, and they have a study that they're currently working on as well. We want to bring our energy provider on board. These are very energy intensive. Our carbon capture and the sequestration system is extremely energy intensive. It will take double the energy needs of our cement kiln operation to support a carbon capture and sequestration system. So we need to bring our energy supplier on board because we don't want to increase our CO2 emissions from our scope 2 because our energy provider, which they still are using some coal and some natural gas. So it helps that they actually are doing carbon sequestration, right? Helps their scope 1, helps our scope 2. We also, as part of our study, are looking to see if we do a combined heat and power system to generate our own power, which we aim to do. And that's what our Edmonton plant is doing. Oh, no, I apologize. They had looked at it there, that we're not doing it. The difference is for us, it's cooling. Canada doesn't get hot. Right, so our cooling needs are much more intensive than what's needed in Canada, which makes our energy needs goes up, makes our water needs go up too, or our carbon capture system. So that's something else I've been voicing a lot in our project, like, hey, we need to make sure we're mindful of our water use, and thankfully some partners are helping us out with our hydrology study there. We're really trying to, and we did look at that for our K4 system. We do use a recirculating glycol system for some cooling on our K4 plant. We're also looking at part of the cooling system at least being a recycled glycol system, maybe reusing water that would be discharged from the cement plant to use as cooling for the carbon capture system, cooling water there. So we're really trying to make sure we're, fully, don't want to just, hey, we're not doing CO2. Oh yeah, shoot, but here's a lot more water. Like we're trying to be really mindful about that. So community outreach and engagement, I know I'm running up against, lunchtime here, but we do have a community benefits plan that's associated with our entire project. We estimate that this will also have over 1,000 construction jobs during construction of this project. Actually, it says 25 there, we think 25 to 30 permanent jobs. This will involve highly skilled and highly skilled workers and job training, and we will provide that training. We have will continue to provide, our world here in mining and cement, these are good paying jobs, above kind of the average wage here, and we will continue to do that. These are kind of the elements again. I was doing so well earlier, but I tend to talk a lot. So these are kind of the elements of our community. There we go. So good. So yeah, there's, we can talk about this all day, but we're really excited. We're trying to, as I said, we're working with Duke Energy. We're also working with BP. So BP up in Northern Indiana has carbon capture and storage that they're looking into. They also have a hydrogen hub that they're participating in up in that area. So we're working with other businesses to try to educate the community. We reached out to Purdue Extension. They're going to be providing some education resources. We're trying to maybe find another author to really get some information out to people about what carbon capture and sequestration is and what it isn't. How it can be done safely, why it's safe, and what the need is, right? Again, when I said those of you from Indiana, you remember what our winters used to be like. We had one snow this year, maybe two. Like my kids never even busted out their snow pants or sleds or anything this year, right? We're just not seeing it. It's real. Climate change is real, right? And we have a responsibility to try to mitigate that as much as possible. So, it's exciting. It's exciting to be the first carbon neutral cement plant here in Mitchell, Indiana, right? Like in the United States, and we're here in Mitchell, Indiana. It's exciting to be part of it. It's putting Indiana on the map. It's putting our company on the map, but it's putting Southern Indiana on the map, which I think is fantastic. I'm excited to be part of it. But, for me, this is kind of a once in a lifetime project, right? To say I participated in this. So super excited to be part of it. But, that's one of the reasons why we wanted to kind of, bring you all down is to hear about it, to learn about it. And, when you're out about that project and we welcome other people back any other time, right? Later on, we're doing some construction, or if we have any geologists who want to come out when we start drilling and come take a look at it, we welcome you back. Because we want to be able to provide as much information, be as transparent as we can about our project. So I'll take questions.
So I'm assuming that Europe, probably there's a pretty good market for greener concrete. So I'm curious about markets in general and how are things looking in the US?
Yeah, so, as part of part of that we have to do a business case, so we're working with a third party to put that together. Yeah, there's a carbon tax in Europe, right? So it makes sense. It's a little easier to swallow some of these price tags. We don't have that here in the US. So we're really, there is a tax credit called 45Q. So that tax credit will provide, it's a credit of $85 per ton. It's a 12-year, so it's limited, right? So that's something we need the government to extend that beyond 12 years. We have to have shovel in ground by December 31st, 2031 in order to be eligible for that tax credit. So that's something we need government help with, like extend that 45Q tax credit. There's also other, I mentioned earlier, there's other technologies that we are exploring, right? This isn't our only lever. We're not putting all our eggs in one basket. We need the government to expand that 45Q tax credit to maybe some other technologies where we can take advantage of that as well. But again, we got to hit the market. We need procurement. I mentioned earlier, the federal and state governments are kind of our customer, the end users for, I believe I just heard it was like 60% ultimately of our product. So we need government procurement to kind of come along and, require lower embodied carbon cement as part of their procurement policies. We've developed what's called environmental product declaration. It's like a nutrition label per se for our product. And we've published it to show what our global warming potential is of our products. So EPD, we don't develop it ourselves. We provide data to a third party. And they use an ASTM standard to develop the EPD, and then that's certified by another company. So that really then compares products from a cement company to a cement company. So by having those EPDs published, people then can compare when they're choosing their building material. So, we're looking for customers who want it in the market, like I mentioned, the Meadows and big data centers who want to have green building materials. Architecture firms are, there was a national architecture firm that said that that's where they're going, that they will only be using these kind of green building materials, when they're doing their construction projects. So the market's going that way. But we need, government procurement will go a long way to help that, extending that 45Q tax credit. And then we're looking at other, mechanisms to help fund. So it's not just, all being passed, the cost aren't all being passed on to the consumer. Okay. Other questions? Yes.
Thanks, Wendy. Thanks for all the details. Great presentation. My question has to do with one of your very initial slides on water management.
Yes.
Corporate slides you were doing. This group and others in Indiana for quite a while now have been saying water is going to become a priority around here, and I think it's finally arrived. Lebanon announced the other day that they're not going to allow any more development because of lack of water resources. At least that's the way I read it. So you had mentioned at the corporate level, you had some high priority sites designated and they need to do water management plans. Are you able to share any kind of just general angles that the different facilities are taking in their water management plans?
Yeah, so we actually are just launching that. So we started that 2 weeks ago, started working on that. This particular site is not designated in a high water stress area. It's likely we will eventually put water management plans for all of our plants. So we're starting with some of our sites up in the Chicagoland area. So, what we're first identifying, we started actually a year and a half ago, Jeff, we put together, water diagrams of where we are measuring all of our water right now and kind of what our flow looks like, what's incoming, where it's being used, where it's discharged. So now this is taking it a step further. So first we're identifying efficiencies. So we're looking at, so if we, as an example, if we have a pump that's rated at a certain capacity, are we really getting that capacity out of our pumps? So that's kind of the first step is identifying water efficiencies. And then looking for, as part of those water management plans, looking at reuse opportunities. So when we have our wash products, as I mentioned earlier, are we collecting the water and reusing it where possible? We use a lot of water for dust control. Are we using that in the most efficient way possible? And if we're using water for dust control, are we getting that from surface water? Or are we getting that from maybe water that we can reuse from someplace else? So, those are the types of projects that we're looking for, is that we are just launching that literally like 2 weeks ago. So we're hoping to have our high water stress plants done, extremely high and high water stress plants done this year. But it's really trying to identify where we're using it. Are we using it the most efficiently, minimizing our surface water intake, eliminating it if we can. Those are kind of our focuses.
That's kind of what we've seen in some sites where when the energy efficiency programs are starting to take off, do a treasure hunt for compressor hoses that are leaking. There's kind of an equivalent for the water that we can plants to look for leaks and hoses and dripping taps and that sort of thing.
Yes.
Like, what's the environmental danger of the liquid CO2? So I work in the shale gas region of western Pennsylvania or central Pennsylvania, and you have So well casing leaks on a 2,000-foot well, they get natural gas in their water, they're even like a sink on fire, right? And what is the danger with CO2? You know, if you're having, you know, even with a leak on, say, well casing at 7,000 feet, if it does get back to the groundwater, like what is the actual environmental concern of CO2?
Pretty minimal, right?
Yeah.
I mean, CO2 is already all around us. We breathe it every day. We're around it every day. It's used in its highly pure form. And as I said, sodas and other capacities. So that's part of our, education effort, that this is not a toxic, chemical. So if perhaps it would get to somehow find its way from 6,000 feet below, a leak to surface, eventually it would dissipate. We're already emitting it now, right? So it really wouldn't have any additional impacts than what it already is happening. It would, evaporate into the air, kind of what it is now. There was a pipeline accident down in, I think it was northern Mississippi, not too long ago, that made the news, from a CO2 injection pipeline. I think there were a few injuries, but there were no severe injuries or deaths or anything from an actual CO2 leak that happened down in that area. So, it's not a highly toxic chemical, so very minimal. Good questions? Okay. Well, lunch is here. Okay, so yeah, we do want to just, we had our race on the tour, it is gonna be hot. So, make sure and grab water, we'll get some lunch, and then we'll go for our tour. It's gonna be a walking tour. We will start here, we will walk out. We will be going up, for those which we're gonna split up into groups, we'll be going up to our tower, the top of our tower, which I think is 7 stories? How tall is it? 10 stories. If you're in some areas, it's actually like a graded walkway. So if you're afraid of heights, you might not want to go to the top, but it's a great view. It's a great view of the plants. You can see out into the quarry. We will do a little bit of a virtual tour as well, since we cannot take everyone out to the quarry. But it's a great way to just even see this beautiful Lawrence County. We'll come down from that tower, go over to our new building, and that's where our lab is, and our the control room for the cow. You can kind of see, you'll be able to see into, at least on a screen, into the burners. And then we'll walk back here. You're gonna get, I'm just warning you, it's hot, dusty, but we're all out before we go out. So go ahead and have some lunch. And water's in the fridge if you need them.
Is the stairway, is that those?
Yeah, I mean, it's like a great, you know what I mean? Like,
I've been in power.
well, I will. Technically, bear with us with a few minutes, or while I get the chair. I actually, come through, I have some videos of the, actual transplant that I might try to pull up and show you guys real quick if I could. But, since we can't go to all areas of the plant, I wanted to show you a few. So we use a lot of heavy, mobile equipment. Oh, hold on. So these are wrapped around, right? So, just to give you a little bit of a, scale of some of the equipment. That's a loader. Yes, that's me. So you can see how big some of this equipment is that we use out in our plant here. So this is the actual Mitchell quarry. Sorry, we couldn't get both to display here. This building right here is actually a limestone storage building. And then this is our quarry here. Here's some other pictures. You can see how, we don't just go and find things out, right? You can see we have a couple of different benches here that we're mining. And oftentimes when we're trying to mine for materials, And whether it's in the cement plant or even just aggregates, because there's different attributes to each of the rock, well, not all rock's the same, right? We oftentimes have to blend materials, different ledges or different benches to get the right chemical content that we need. One of the things we run into, and Scott can probably speak a little bit to this as well. We actually have certain rock which will actually increase our THC, our hydrocarbon emissions, right? And you're like, from rock? Yes, it does. So we have to, in order to not increase our THC, we have to kind of blend certain benches together to get the right formulation that we need. We also run into SO2 emissions are a problem. So a lot of some limestone will have high pyrite content, and that will equate to high sulfur, which equates to high SO2 emissions. So we'll notice cafeteria happens at our Mason City plant actually quite a bit too. That will, all of a sudden we're like, wow, why are SO2 emissions spiking so much? Oh, we must be in a high pyrite area. Now, I say that it's not like we go, oh, yeah, we have a very structured mine plan, right? So it's not just like we do something and then yes, you know what I mean? Like, so we have a whole mine planning group that helps us with identifying the best management for our mines, the best way to mine. We do a lot of testing of the materials to, get the right blends that we need. So, again, I didn't really know about mining and cement, but there are people who go to mining engineering school, right? Like that's what they do. They come out as mining engineers. It's a great career. If you have any kids who are trying to think of something to do, send them to mining engineering school. It's very great careers. So that's kind of a view of our mine. This is a big picture overview of our mine. Again, you can kind of see these benches here. So this is from Google. You can see here, this is some of the areas that looks, Michael could speak here. Scott, maybe pick up of our stripping. Is this the Quarry Lake here?
I can't see from here.
Okay, we do have an old quarry that is mined out and is now a lake. It's beautiful. We let some of the employees can actually go out there and do some fishing. Is that
This is the old quarry.
Yeah, the old Quarry Lake there.
And this was too, or this little bit here is left, but that was the old quarry. And this is just overburden and that they filled up in there.
So we do use that for cooling water as well. So we will take water from that. So it still gets some groundwater seepage and then also collects rainfall. So we will, or surface water, so we will collect or use that water. So this is kind of from within the quarry. Oh, is this a blast? Yes, we're gonna see a blast here. So if we watch up, give it a second. Oh,
wow.
it's much more impressive in person. I'm not gonna This is the best we could do. So we do get to blow stuff up, which is pretty cool. My kids, how did you blow stuff today? I personally blow things. They don't let me near that. See, Michael said they use dynamite. Dynamite. I don't know. He said that. I was like, Michael, we've not used dynamite since like kind of like 1974 or something. Yeah. So we do have again, bear with me. Here's it. I was going to kind of show a little bit on Google Earth too. So again, you can get the full scale of our property. So we are like down here. Oh, I'm looking at that. You can blame Ida.
They know you're posting an event today.
I know, right?
That's why I can watch it at all.
It has nothing to do with my technical abilities at all. There we go, thank you. So you can kind of get the scale of our property here. So we are all the way up in this area. Here's our quarry, and then our plant, which looks really big, is all the way down here. So pretty small in comparison to the sheer scale of our property. So I do have a quick video I wanted to show. But also, real quick, I thought I found these. The transplant. So this is when we did this in August. So you can see kind of where we've cut out, and this is the area I think we are pulling out of. So this is the transplant project there. So obviously you want to do it when the vegetation has been active. Dormant. You can see a lot of the water, so there's definitely, you can see it's a wet prairie here. Here, I actually have a quick video I can too to show real quick. So literally, the guy, he could just, they picked it up and moved it over and put it down. I mean, that's what they did time and time. Each scoop, 6 acres, scoop by scoop.
So just on a flatbed, did you say, or did they?
Yeah, so they took the scoop, literally put the scoop on the flatbed, like 10 of them, and moved. Drove the scoops over, then the Bobcat took the scoop back out and laid it down.
Wow.
All right, let's try this video now.
How far was the inside?
Not far, like a couple miles.
So how are you, avoiding the same problem in the new site, like with the invasive, with the new wetland site, you said, or the prairie site?
Oh, so that's what we will do active, invasive species control. So we will actively manage that area to make sure that it's not getting encroached on again. All right, sorry.
I love those whistles.
Do you want me to send the video?
Yeah. Okay, so this is just a quick drone video of it kind of goes through different areas, different parts of the process, and then also you'll see some of our equipment. There is no sound to it.
Here we go. There we go. So you can see there, that's the height we would be going up to the top floor with our 3-meter tower. Just kind of an aerial view of the plant. That's our limestone storage hall. That's inside that hall. So you can see there, it actually that's the limestone and then pulls out through conveyor all the way up to the main plant, some of our hauling equipment. So that truck, again, I'm halfway up that tire. If we're looking at 5, halfway to that tire, so.
Was that the raw aggregate that was going in, or was that the blend? Was
This
that
is
the?
our control room. I'm not sure. But we'll get to see this control room here.
I'm in a crusher.
So that's a good, nice view of the kiln. We should be able to walk on the catwalk by the kiln. It'll be hot today. I think it is. So the dome actually, the material is pulled from the bottom of the dome. That's clinker, that intermediate product. They're like golf safe balls. And those are silos. Oh, there's Scott. There you are. Look at you.
Can't get rid of it.
There we go.